Assalamualaikum and very good morning to all. So today I would like to discuss about the third part of fuzzy logic, which we had covered during the class room session. So for today, basically, I will be discussing on this. I guess the one that reflected to this. Oh, sorry. Yeah. Okay. So we did discuss about this last week. So this one will be the new things that will be discussed for today. Okay, right. Before I forgot the thing, basically we did discuss about this last week on Thursday, right? Um, the max and min. Okay. Uh, so this is one is this. This one is this, right? Okay. So what we did last week is basically discussing on the ROS fuzzy composition relation basically related to the max mean relation of elements, right? So in other way around, basically we can say that max mean is basically the max and mean of conventional what we talk about matrix product. Okay, so whereby what we did last week was this would be this, and then this as the second one is to be this. So we'll find out the mean for that particular thing. We have this number and we also have this, and then we compare the max between those two, right? Okay, so for this time around, okay, I did give to you as homework. Is there any sharing session for today from you guys about red, blue, green, and black from A side and B side? The thing is basically, oh sorry, where's the point? Okay, all right. So this one would be the first, okay, and then the second. Right, this we have this around, and then as the third, and this one as the fourth, and then as the fifth. Fifth, and this one is a sixth. So 3 times 4, or 4 times, was that 2, right? So what we have is 3 times 2. So meaning we have 1, 1, 1, 1, 1, 1. So the final answer would be this, guys. Okay. So next is what is fuzzy. So I hope that you guys can do it by your own and try to discuss among yourself. So what is the idea of this example number? Okay, this is not example. This kind of exercise. Okay, all right. Exercise. Okay. So then the next one will be what is fuzzy thing related to the things that we discussed so far. So which one is fuzzy, guys? This or this? For common sense, as far as we did discuss from week 1 until week 4. So basically we did discuss about the what they call it Chris set, and the other one will be fuzzy set, right? So this one is, oh sorry, this one could be this one could be that. All right, so which one is which? So this one is could be this one probably will be Chris, right? This one is fuzzy. So the moment that we have the, what they call it, linguistic terminology, so what we do have here, as example, okay, right. So from here up to here is this one, right? Sorry, my straight line is not very clear for you guys, I think. But okay, so this one, okay, right. So this one is, we could say, in the linguistic terminology, is very tall. Okay, example. So this area will be tall enough. Okay, so while this one is tall, this one is quite tall, this one is, what they call it, short. Okay, so the things that we have over here is linguistic terminology, like what we do is very tall enough, still tall, or tall average, or things like that, basically related to the language terminology. So what we have here is this thing. Okay, regarding to the Chris example, so this one should be A, this one is EB, right? So this one is A dot B. This one is product of Boolean, right? So this one is Chris, meaning 0, 0, 0, right? So the idea is, this one is considered as 0 tall when somebody, or when the kids is basically having the length, the tall height as 32. Consider tall as that some certain of age, okay? Like 2 to 3 years, maybe. Okay, so below than 72, basically we did consider as not tall. Okay, so that would be Chris. So however, in fuzzy, the things that we discuss over here are very tall is 1.0. Tall enough is, what is this, guys? 0. Let's say 0.65. Tall bulat 0.35, and this one is tall, let's say, is 0.2, and short is 0, right? So this would be things that, this one is how to say, elements. And what about this one, guys? Mu. Okay, so what is this, guys? Oh, sorry. So what we call it, membership. Okay, so the degree of membership reflected to the value from 0 until 1. So that would be happening over here. So the segregation of valuing the elements that we have in Crispy, we don't have. In Fuzzy, we have this. Okay, so that would be the things that reflected to the Fuzzy, whereby later on we will talk about this. Example, this is mu x, or this one is x, for example. Oh, sorry. So this one is the range of something, the fuzzy thing. So meaning from here, 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 here to be here, right? So that would be, for example, 25 to 35 degrees Celsius. So the fuzzy for that particular thing should be membership of 25 is 0.25, for example. So that would be particular thing happen in air conditioning or refrigerator fuzzy controller system, right? Okay, so then hold on, can I change the color then? In color, okay, all right. So then say that we have mu x over here. So what will be if, say this one is a, right? Ax mu dash. So mu dash is basically the opposite of this one, right? So this. Dia terbalik Dia bukan it's not like the things that related to this. If the component of Chris when A is 1, so A dash would be 0, right? So similar as this one. Dia terbalik So this one would be 1, this one would be 1 at that side. So meaning A is 1, A dash is 0. When A is 0, A is 1 dash. Okay. So same goes to this. Basically, there will be inverse. Okay, from that particular mu in the context of fuzzy sets. Okay. So this one will be dash. Right. Okay, then the things that related to the fuzzy 2 are allowed to deal with the real world number. So basically, what we did over here is not really meant to be as a true for 1 and false for 0, right? So meaning A plus B equal 1 or 0, right? So that will be depending on this. Okay, so means 0, 1, 1, 1, right? So meaning this is true, this is true, this is true, this is false. That particular. So but however, we have this one is true enough. This one is mostly true. Example, we change it 0.8. So this one is half true. 0.6. This one is kind of true. We put it 0.4 over here, while false over here is 0. So that would be the range of 0 until 1, but happen to be has the fuzzy level degree of membership, right? Okay, so the value range from 0 to 2, including the decimal value, for example, 0.2, 0.7, is basically happening in this graph, guys. Example, we have this, we have that, we have this. Oh, sorry. So this is supposed to be here, and this is x maximum will be 1, so this one is 0. So basically this will be 0.2, 0.4, 0.6, 0.8. So 0.2 is over here. So this is basically reflected to the things that we have in the discussion before. Example, when we did discuss last week, we have large number, right? Ingat tak yang contoh Lee Chong Wei? So we have small number, right? So we have largest number, larger and largest number, yeah, right? So that would be the thing happen in the fuzzy. Okay, so the things that happen between 0 until 1. So not happen from 0 to 1 only. Okay, that would be the idea of this slide. Okay, how fuzzy logic solve our daily problems? Okay, take a look at this example. Example number 1, we process data. So the given fuzzy set can be used to add in decision making of management. Okay, right. So the keyword over here, decision. Where's the ink color? Okay, so decision making means either we decide or not to decide, right? Or manage. So this one could be another thing. Decision making meaning we try to control, in other words. Okay, so to manage means, so we try to manage from outside. So this one is internally. So for example, external. So we do have acorn over here. Example, so the acorn is blowing the air. This is the acorn hanging on the wall. So this one is the product name NMZ acorn. Okay, so this one is bad. Okay, say that the temperature of the room is 35 degree. So then that will be considered as room temperature. So internally, the temperature will be 20 degree, for example, right? So in order to do this, basically the fuzzy controlling system happen inside the acorn, a cooler air condition. Basically try to find out the internal temperature, external temperature, and then how the fan is producing the air. So meaning, is it compulsory to speed up the energy of the fan. So meaning the airflow will be high, depends on the definition of temperature. And it could be also humidity of the room and inside the units of aircon units, right? So that would be several particular things. So whereby we can see over here, speed is actually the demand for the control, and temperature is the demand number 2, and humidity is demand number 3. So this will be the 3 elements need to be considered by Fuzzy in order to control one air conditioning system. So that what we have in our common life, for example, right? Okay, so then we do have example over here, given 4 jobs. So example, job number 1 is very subjective. It could be Panda, it could be Grab, it could be Lala, Move. What else? This one is JNT. Example. So our task is to choose the job that will give to the highest salary given to the constraint that job should interesting and close to home. Okay, right. Okay, so the keyword over here. So I'll change the color for a second. Hold on. Is it blue? Blue would be nice. Okay, right. So the keyword over here is interesting and close to home. Okay. Right? So then the other one is salary, guys. So there will be 3 domains to be considered. 1, 2, 3. So that would be the choices how we set the fuzzy logic between the 3 components: higher salary, demand, interesting, enough for that particular job or scope, and close to our home. So similarly to this one, speed, temperature, and humidity. So okay, right. In order to portray the fuzzy logic in what we call it in fuzzy system sets, so we put it this way. So one is interest. Okay. So the other one is drive. Drive meaning the long or the distance that the future worker should drive to reach to the workplace. Okay, then the salary one is the last. Okay, right. So then fuzzy sets mean, so this is the set. Okay, I'm here right now, so I will change again to green right now. Okay, so this is set, guys. What is set, guys? Okay, set does mean that we have what we have in the previous class. Is it R? Is it S? Is it Z? Is it X? Which one? So this one is X. This one is X, guys. All right. So X basically considered as what we call it universal set for that particular numbering component that we have. Okay. So right. So the moment that we start our journey, where's my pen? Okay, here. So the thing that we did is A, right? Remember? A is subset, fuzzy subset for the X, while B also could be subset of X, right? So this one, this time around. So this is subset of fuzzy, this one too. All right. So now the interest is basically the fuzzy subset which lay at the X in. Okay. So universal space for that interest particularly, we have 3 kinds of numbers over here. So this one is minimum. This one is maximum element that we have in that particular point. Okay. And then we have this. Where is it? Okay, I'm here. So this one is 1, meaning 1, 2, 3, 4. So this one is increment. Okay, so meaning minimum is this. So the maximum is this. Okay, so the increment is this. So meaning to say that 1 is the starting point, 4 is this ending point. Well, 1 is the increment point. So meaning we have 1, we have 2, we have 3, we have 4, right? So the same as this one too. We have 1, we have 2, we have 3, we have 4. We have 1, we have 2, we have 3, we have 4 over here based on this. Okay, right. So what we do have in the number over here, guys. What is this number, guys? This one. What is the blue? Oh, sorry, this one too. Example, I put it this way. 1, 2, 3, 4, 1. This is 1. This is this. This is 0, 7. This is 0.5. This is 0.2. So this one is basically mu. Okay. This one is a subset of let's say this one is salary, guys. This one is x. Okay. So the point that I mentioned earlier about the blue circle is basically membership function, guys. Here, where's my this all the thing. Okay. All right. So I think that will be okay for you guys now to know that about we do have the interest subset, we do have drive subset, we do have salary subset by the given each of the membership value. So for example, interest 0.4, 0.6, 0.8, 0.6, drive 0.1, 0.9, 0.71, while salary 0.875, 0.7, 0.5, 0.2, right? Okay. So we try to portray by the job itself. So okay, then again I try to change the color. Purple this time around. Okay, so the job is basically here, right? Oh, sorry. Where's the pen? The job is here, guys. Job 1, job 2, job 3, right? Job 4. So each particular job over here, 1, 2, 3, 4, is basically portrayed by this graph over here. 1. Oh, sorry. Okay. Right now I try to go this way. Okay, so now is job number 1, job number 2, job number 3, job number 4, right? But it relates to the 3 domains that we discussed right now. The set of interest, the set of drive, the set of salary. So lay down in the subset of X, right? Okay. Okay, right. Okay, right. So then what we have over here, 0.4, 0. This value blue is basically taken from here, guys. 0.4. This one is 0.1 is taken from here. Where's my pen? Here. And 0.85. So this would be the things. So from this perspective, we can see that each of the job 1, 2, and 3. Okay, so we can see that this one is basically kind of okay one rather than this. Okay, depends on the job, because this one, what is this? Drive. Okay, so drive meaning short distance. So this one could be better lah. So in terms of this is long distance driving, this one, right? This one too. So for those people who are finding the short distance of workplace, would be this is better. But the thing is the interest is not so strong, okay, of that particular job for that particular person, but the salary is high. So that would be the trade-off that we know from the fuzzy things, right? Okay, so this is the one the same as before. Okay, take a look at this one, how fuzzy logic solve our daily problem, guys. Okay, all right. So this is example car maker. Car A, car B, car C, car D. This will be the price for the second column. CC, the engine capacity, 2000, 1003, while this one is seats. Okay. So speaking of which, basically the car for A example. So from price range, we have what we call it, price domain, CC domain, seats domain. Okay, right. So we have the X, for example, right? Right. So in that particular X, universal sets. Okay, so for that purpose, basically we try to make things become fuzzy. So which one is the highest, do you think, from the price? So the highest, let's say we put it 1 over here. So this one, it could be 0.8 over here. This one is like fish. It's quite small. Sorry. We put it, this one is 0.65. Right? So then we go to CC, etc. So the highest is 1 over here. Is it? Okay. This one is 0.8. This one is could be 0.4, for example. This one is 0.2, guys. Okay. So depends on the one that we discussed about last time. Lee Chong Wei preferred large number or small number. Remember that? Okay. So then this one will be 1. This one will be 1, 2. This one will be, what's that? 0.7, for example. This one is 0.2. Okay. So then we shall have the parameter, the membership degree of each. Okay. Same as the job one. So meaning A, B, C, D. Okay. So the A is basically 0. Oh, sorry. This one is 0.0, 1.0. So this one also 1.0, guys. Okay, let's we talk about A. Okay, A is 0.65. Example here, approximate. So 0.8 over here, 1 over here, guys. Okay, for B, 0.6 approximate, same as A. 0.4 is this. Okay, sorry. 0.4, 0.7 is 0. This. Right? Allah. Okay. 7, right? So then we go to C1, 0.8, a bit higher. Okay. So then this is 1. This is 0.2, guys. 6. Okay. So then this one is could be 1, 2. Okay, this one is quite pricey then. So but the CC is 0.2. Oh, price, okay. So but the 6 is good. Okay, so you can just imagine that the variable is different based on the membership function or degree of the membership. So we might know that the preference of the first would be the price. This one is the capacity. This one is the seats, PCS. So whereby if we take a look at this, comparing to the price, basically this one is the expensive one, right? So that would be the idea of putting the fuzzy logics in our daily life. So similar for example, you are given the assignment for instance. So this one is A person, B person, C person, D person. So example, time management of the person, the what else? The characteristic of person, deadline, and then time, deadline, and quality of assignment. Example. So then you put it. This one is Ali. This one is Baba. This one is Chong. This one is David. For example, So you put it the value. So you can play around with a fuzzy in even in our short distance or small skills of our selection control life. Okay, so fuzzy logic control. The theory of fuzzy logic based system could remain fuzzy till one discover how to apply it to the problem. Okay. So thing is, when we talk about fuzzy, obviously still in fuzzy, example, this range, for instance, the idea of speaking about 1 to 0, so that would be still fuzzy. But at the end of the day, how we decide that the final output or inference that we have for that particular control system is to be applied in order to find the solution. Okay. Later on, we talk about this using the A cooler system. Okay. All right. So fuzzy logic has been used in a broad spectrum of application range. So this one is we talked about last week. We have a washing machines, camera, the most sophisticated one that include the turbine control, tracking data, and classifier. So this would be the most common thing. Okay. So speaking of the washing machine, so this is the inner of the washing machine, right? So the drum that we have inside. So speaking of this, the water, how the water could be, the volume, okay, could be put in when we put the clothes at this length, at this height, sorry. So meaning this is the cloth, guys, clothes, trousers, clothes, trousers. So in that particular instant of sensor, so the could be the height, could be the weight, right? So it could be weight before water, so could be weight after water has been filled in the drum. Okay, so that one character. So according to the weight, basically water is basically the selected by that particular fuzzy control. So then again, we do have, so I think you should familiar with this normal wash, what they call it, speedy wash, right? Warm wash, gentle wash, kid and toddler punya stuff, contoh the kind of fabric things. And then we have again blanket, so that would be the idea of 1 category, 2, 3, 4, 5, 6 category at that particular washing machine menu. Okay, so that would be controlled by fuzzy. So because we don't have the 0, 1 kind of condition, but we do have several elements. Speaking of water, volume, we have weight, we have the, how to say, the cleanser liquid. So how much should we put in the washing machine, and etc. Right? Okay, this one is the idea of the fuzzy logic control scheme. So basically, we have fuzzation, the defuzzication. So the idea of having this at the first glance, and this one is the rules. This one is defuzzification. So things like that will be happening based on the idea of this has been set and this. So for example, a condition, how you set the fuzzification to on the acorn, and based on the temperature, humidity. Okay, right. So lately, if you went to the home appliance store like Sankey or somewhere, so basically from 10 years back or 6 years back, there will be a human sensor which they put it infrared over here. They pull down the radius of sense, so tracking the axis of human. Is it the human is sleeping or doing activities? It depends, but the aircon will be decided by the fuzzy one, so to control the room temperature, then the humidity and so on. So that would be the good idea compared to the normal one, depends on the humidity, temperature, and what do you call it, fan speed flow, producing the air flow rate. Okay, so that would be the kind of things like Panasonic one. Recently they do have what they call it, humidifier. They do have Ion Alpha, Ion Beta. I'm not sure about it, depends on the brand. So ionizer, so meaning to say that if the room is basically happen to have minus charge or very electrostatic one, so they will be pushing the positive charge to the air, so meaning to neutralize the air. So it's not about the air conditioner per se, but it will be relating to the ionization, humidifier, cooler cooling and tracking the existing of the people in that particular room, either the what they call it, the person is lay down statically or moving actively. Okay, right. The Okay, speaking of the fuzzy room cooler, so this one is the one of the example that we have for today. So we assume that the conventional room cooler, so this one is the keyword right here, conventional. It's not the latest one. Room cooler implementing using, okay, one is the fan. So this one is the fan. Okay, so motorized pump control to rate the flow of water required for moisturizing. Okay, this one is motor, right? So two sensors mount inside, as I mentioned, in and out. Okay, so this particular sensor will be embedded in and should be placed at out. Okay, so mean in and out sensors. Okay, in order to react the temperature internally and externally. So the fan speed could be varied either by a knob or by user. So this one is the external influence by the user. So basically, user could manipulate and change the knob based on their reference. So meaning if the person feeling the room is still hot, so the people kind of pressing the controller to be cooler version of the face, like dropping down the temperature or pulling out the speed, kind of. Okay, meaning speed is 1, so it will be add up until 3 or 4 something. And then the basic aim here is to achieve smooth control and also save on water and precious resources. Okay, so that would be 2 things to be reminded here. Smooth control. So it depends on 1, 2, 3, and 4 elements. Okay, so remember that we had discussed about job 1, 2, and 3, interest, drive, and salary, wasn't it? Okay. And then here we have several elements that should be considered by that controlling system designer. All right. So further, for simplicity, we assume that to maintain the temperature on the room, hold on. Okay. The keyword here is maintain the temperature, guys, of the room. Only the rate of flow of water need to be controlled based on the speed and temperature. Okay. Now, in order to maintain the temperature in one cube room, so this one is room. So imagine this is bed, this is window, this is table for the study, and this is desktop, and so on. This is aircon. So cooling this one. Okay, all right. So we assume that to maintain the temperature in the room, so let's say 25 degrees Celsius consistently at 2 p.m. until 5 p.m. So meaning this, to maintain the 25 degree of temperature internally. So we assume now only the rate of flow of water, okay? So cooler lah ni, bukan aircon lah, cooler. Flow of water need to be controlled based on the speed. Okay, so this flow, where's my pen? Okay, the air coming, hold on. I think I should change the color. Okay, the air coming here is basically controlled by 2 things, speed and temperature. Okay, so the air which going out from this cooling system is basically controlled by speeds and temperature. Okay, so then with this infrastructure, we designed the fuzzy engine to control this chrome motor. Okay, so now this is the time that we need to design the fuzzy based on this water, speed, and temperature. Okay, so 3 things. So then what we do have is 2 parameters involved, which we have discussed just now, which I put it in red font color. So we have speed and temperature over here. So temperature and speed decide the water flow, right? So this particular factor will be deciding. Okay, right. So means for this particular aspect, temperature, we have cool, moderate, warm, and hot. For example, 0, 0.2, 0.4, 0.6, 0.8, right? So that would be things that related to temperature. T, based on X, depends on the fuzzy subset stain based on X large. So then the second thing is we define the fuzzy terms by the speed. For example, low is 0 and etc, etc, etc. So we have the membership function for that particular green font, low, medium, brisk, and fast. So low is 0, for example, fast is 1.0. So then we define the fuzzy terms for the output system, which is the flow rate. Okay, remember here, only the rate of flow water need to be controlled based on. So this one is based on speed. So this one is two parameter that we discussed, 1 and 2. So from here, we have to decide the output, which is rate of flow water. Okay, so okay, right, written here, flow rate of water. So that will be the destination output for our system for this fuzzy room cooler. Okay, so then what we do have for the output, we have how many outputs over here? We have 7, guys. Okay, strong negative, negative, low negative, medium, low positive, positive, and high positive. So it depends on the speed. Example, this is 0, this is speed. This one is, it depends on speed, right? Okay, this one is could be 1 kilometer per hour. So this one is 2, this one is 3, for example. So this one is the highest airflow speed. So example, 10 kilo m. Example, eh? So that will be increment as the final target for this controlling system, right? Okay, so therefore, with the real data available that we now set the temperature as what we have just now, what we have, low and so on. So the speed we have here, oh sorry. So this one is not this one is cold, this one is low. So how about this one is negative P and LP and so on. There will be 3 components that we need to assign the membership. So remember this one. Okay, this one is something to be filled. Okay, so or we can say that this one is could be this, right? Dot. Okay, anything. Remember the membership function to the respective value and illustrate the graph. Okay, so meaning every each of the temperature, speed, and flow rate is reflecting to this by having their own value. Okay, respective value. Okay, for cold, cool, moderate, warm, and hot. All right. To do this, from 0 until 10. So the definition of cold is happening here, guys. So this is cold. Okay, based on this idea. So meaning the cold is happening from 0 until 10 degree. Okay. So but the thing is, from the 5th to 6th over here, we can see the membership function is decreasing, guys. Okay, we can see here, or we put it this way. So the decrement of membership function from the core, from 1 fully core, is basically jumping going down, decreasing, from 6 then, is it 6? Okay, 5.55. Okay, so there'll be decreasing of the membership. Say that we have 7, for instance. Okay, 7. So the membership function is here, guys. Okay, 0.5, for example. Okay, so that the range of that particular membership function, or we call it the level, for the cold. Okay, so for the cool is stating that we the environment of the cooling system is happen from 7 to 22. So this range. So this would be the degree, right? Okay. Right. So at this region temperature, so the membership of this kind of things happen incrementally and decrementally, okay, by this range. So that would be the idea of cool, right? So same goes to moderate, warm, and hot, etc., etc. Right. So then speaking of the fan motor speed, the same. Slack meaning 0 until 7, so things like that. 4 until 19. Is it the same? Oh no. Okay, see. So this one is 4 to 19 for instance, low. So because that will be focusing on that particular fan motor speed. Okay. So that for temperature, it's not really relevant to set for the 4 to 19 because temperature is different than that. Okay. So medium is this, the brace is this, and while fast is this. Okay, all right. So that would be the differences between degree of membership based on the membership function for that particular x. What is x over here? Is temperature. What is x over here? Is motor speed. What is x over here? Is flow rate, guys. Right. The same goes to the flow rate, which reflected to the final inference or output for that particular system, fuzzy room cooler. So we have what is SN for? Hold on. Okay, strong negative. Okay, negative, low negative, medium, low positive, positive, and high positive. So that would be target for our system depending on temperature and fan speed. Right. So then we set the fuzzy rules that we have. Example, R1 is temperatures hot and fan speed is slack. So meaning this one is this one is that. Okay. So meaning HP is high positive, guys, because of the hot and the speed is slack. Okay. So meaning N condition. Okay. So it goes to the same way when we talk about hot and fan water speed low. So meaning it could be twice. It could be twice time to use the HP as our target for the outputs. So see here. So then hot and fan speed is medium is P. Okay, this is high positive, low positive, and so on. So because of this one is hot, this one is warm, but this one is medium, this one is brisk. It depends on the level that we set for that particular rules. So example, we do have 0, 1, 1, 1 for A plus B, right? That would be simple. That would be similar as that particular concept. All right. Fuzzification is things that related to the prior process, gaining the sensor inputs. Likewise, we can see over here. Right over here. Fuzzization, right? This in the left. Where is it? Here. Okay. So while defuzzization is basically the reaction based on demand that happen in sensors in and out from the cooler system devices. Okay. So this first convert each crisp input into a fuzzy input. Okay, on the domain on the input variable. Okay. So in this fuzzification, convert crisp input into fuzzy set. Okay. So this time is fuzzification is basically converting the crisp to the fuzzy sets of label kind. Okay. So whereby we have this argument on the domain input variable. So it is performing the heart of fuzzy engine. So basically before going to the engine. Okay. Whenever the sensor report the value of the temperature and fan speed, they are mapped based on the membership. Okay, remember? So we have sensors in and out. Okay, based on temperature and speed. Okay, in and out. So then the fuzzy will be controlling based on the membership that has been selected by us depending on the low, cold, cool, moderate, and so on and so forth. Right? Okay, this one is the example for fuzzification. So if at some instance of time, the temperature is 42 degree, guys. Okay, so I just underline this thing, and fan speed is 31 RPM, rotation per minute. All right. So based on membership, degree of membership, okay. So we knew that we have temperature, right? So this one. We knew that we have speed, guys. 2. Temperature is basically the specification has been given to us is 42. So means we try to go down and find 42, right? So we have two things over here based on this hot kind of things or the warm, okay? So the moment that we have 42 degree over here, we have 0.142, this point. Oh, sorry. So this one is 0.2, guys. Oh, okay, I go here, cross the one, go here. So there will be two membership level for that particular temperature. So mean related to warm and hot both. Okay. So this and this. So then, oh sorry, back. So then we went to 31 rotation per minute. Okay. So this one will be the second thoughts that we have in order to control the fuzzy system. So we have two things: medium, this over here, and brisk over there. Okay, so 0.25 is basically happen here, and this one happened to be here, 0.28, right? So there will be two conditions each. Okay, right. So that would be the pacification before going into that particular control system. But diffusifier is from that particular rule that is set by the fuzzy set. So we have three kinds of thing: LP, P, and HP. So this would be the things that we need to be selected by this level, guys, rules. Okay. So we have P, and LP, right? So we have even at the beginning we have 4 levels, but the thing is HP having 2 levels at the same time, meaning hot and fan low, hot and fan brisk. Right? So that will be fuzzy level for these two cases, 42 degree and 31 RPM. Okay, then so then we try to check the okay, here remember that we have where is it? Sorry. Okay, so now we have, so now we need to have find this to this, this to this, and then later this to this, this to this. Okay, so 0 to 5, so meaning minimum 0 to 2 to 5, this one, right? So then 0 to 86. So what will happen over here is basically try to find the mean. Okay, so you just fold okay. So 0.2 is the domain. We'll need to react with this and this at first. Okay, the first one is 0.2. Where is it? It's hot, right? And fan speed is 0.2525. Brisk. Okay, so then what we have here is trying to find the level of these two. Sorry, where is it? Membership. Okay, so we try to find the mean 0, 2, 0, 5. So the idea that we have is basically 0.2, right? So 0.2 as the flow rate. Okay, so flow rate. Remember, from two domains, two parameter of temperature and speed, finally we decide the flow rate, whereby A. Okay, so 0.2 is basically here, okay, around here. So then remember, after 0.2, 0.25, then 0.2, 0.286. Okay, the second one is 0.2, 0.286. So then mean. So obviously, we try to find this. Okay. So then we have this. Right? Okay. So this will be rule number 4, HP. This will be rule number 3, R3. Okay, P. So meaning the rule over here is apa tadi? This and this, right? Okay. And then, sorry. So then for the second one is 0.44 to 5, and then 0.142 to 286. So the same thing, right? Then, okay, so this idea reflects us to have 3 level, because this one is 2, right? Remember the one that we have just now? Okay. Okay, so 2 HP, 1 P, and 1 LP, right? This one. So whereby we need to focus on three range of value for airflow rate, right? So we have LP for this particular moment, this and this. Okay, there are two ways to achieve the diffusification, okay, which are center of gravity and composite maximum. Okay, right. So please remember this one, guys. All right. Okay. One, two. Depending on the application, either the center of gravity of the composite or composite of this region area is found to be treated as the Chris output. Okay. In the case of example, both way could be used to find the Chris value. So because this one, eventually we have the things that close related to each other. This, and this. Example, if we do have example this one, this and that will be not very centroid. Okay, that will be depending on the composition. Okay, composite maximum, right? So eventually, for time being, the only things that we have is just nice. The idea of output is basically side by side. Okay, uh, blue, blue point, right? Pen. Okay, so eventually we have side by side this, and this. So then we try to find the centroid. Okay, the idea of the center of the gravity. So meaning whereby we try to find in the middle way to find the all solution for that particular what was the temperature just now? 42 degree, right? And then 31 R P M, right? So that's the Chris value at the end. Okay, so see here, even though we have the level for temperature, uh, what do we have this now? Speed and flow at the end. So every each having the membership value, right? So this one also have the value. So even though we have the membership value, at the end of the day, we try to harmonize the Chris value as the output of all this system. Okay, so that one is in the case for example, both way could be used to find the Chris value. So Chris value is basically the final destination of that particular fuzzy room cooler. Okay, so dia tak mungkin ada dua solution pada satu system. Okay, meaning giving 42 degree of sensors, 31 RPM speed, what should the air condition do? So kalau if the output is basically having the fuzzy too, so meaning the aircon is upside down. So sometimes going to up, sometimes going to down. So there must be a Chris value at the end of the day. So that would be the final value for fuzzy system. Okay, so in the case of non-control applications, as the decision whether, okay, this one is the idea of when we have non-control application, deciding whether a book or artificial intelligence belong to the domain of design and so on. Okay, so either this, psychology or civil, in such situation, using center of gravity may carry no meaning. Okay, right. So it depends on this because the computer science, psychology and civil is not correlated each other. So that would be no point to use, no meaning to use the central of gravity. Okay, so we can't really relate the science, computer science, which this keyboard, psychology, brain, and civil engineering, building, example. So that one is not correlate each other. So there will be no meaning to take it central. So meaning, can computer science be centered to the psychology, and can be the civil building would be centered from technology. So that would be no meaning, right? So for that instance, composite maximum is generally used to solve the diffusification. Okay, right. Okay, I think that would be the end of the slide for fuzzy chapter number 2, if I may say. Okay, thank you guys for watching NMZH channel. Hopefully you can get knowledge and benefit from the videos. Thank you so much. Assalamualaikum.